So, trying to finish the rest of this then. We found out here that we were speeding up from 2 seconds to 3 seconds because velocity is negative, it's below the x-axis, and it's decreasing here. The function for velocity is decreasing, so acceleration is going to be negative. Signs match, so we're good. Going on to the next piece, we know here velocity equals to 0. Acceleration, we can't really tell much because it's constant. So since we've got here no real way of knowing, we can't say anything about the acceleration from 2 seconds to 6 seconds. Nothing we can say. Going right along here, velocity is still negative. Acceleration is increasing because the function is increasing. So we're slowing down from 6 seconds to 7 seconds. Now, here in this piece, velocity is positive and it's an increasing function, so acceleration is positive, meaning that we are speeding up from 7 seconds to 8 seconds. And in the last piece, while velocity is positive, it's decreasing, so acceleration is negative, so we are slowing down from 8 to 10 seconds. 8 to 10 seconds there. That's where this idea of speed comes into play. Okay. Now we're going to talk about how far a particle is traveled. Talking about net distance and total distance. So definition of net distance. This is the distance from where the object begins and where it ends. Total distance is the sum of all distances moved. The sum of all distances moved in any direction, left or right. So if a particle is moving in the same direction for the entire amount of time that it's moving, we want to think about net distance and total distance. What can be said about them? In this case, if the particle is moving in the same direction, always to the right, always to the left, however it may be, they're equal. Net equals total distance in this case. That won't always be the case. In this case, that's true. Okay, so to find the net distance a particle travels on an interval, here's what we're going to do. So on some interval, a comma b, the net distance an object travels is the absolute value, because distance is always positive, right? The absolute value of the position, the initial position, minus the final position. Absolute value P of A minus P of B, where P of T is the position function. Okay? Now to find the total distance an object travels. So if the object, there's kind of like 2 points here. If the object travels in the same direction, if it's always moving right or always moving left on some interval a comma b, then the total distance equals to the net distance, and that is the absolute value of P of A minus P of B. Now, if the object changes direction at, say, time c seconds, within this interval, A comma B, then total distance is the absolute value of P of A minus the point where it changes plus absolute value, point where it changes, minus the point where it ends. That would be your total distance. So let's see an example. The position of a particle is given by this function, where position is measured in centimeters. Find the net and total distance the particle travels from 1.5 to 4 seconds. So net distance. Net distance, that's just talking about how far it is from the starting point, is equal to the absolute value, position of 1.5 minus position of 4. This can be all calculator stuff. The net distance is 58.75 centimeters. That's how far the particle is from its starting point, from 1.5 to 4 seconds. Okay, now total distance. We need to figure out if the particle changes direction or not. So this is the position function. To figure out if it's going to change direction, we need to look and see if there's any change in velocity, because velocity tells us left to right. So taking the derivative, 6t squared minus 12t plus 8. And if we take a look at this velocity function, we see that the velocity function is positive on the interval 1.5 to 4. It's always positive, meaning the particle is always moving to the right. Always moving to the right for the whole interval. Not necessarily always, but from 1.5 to 4 seconds, it's definitely moving to the right. So then we can say that the net distance is equal to the total distance, which in both cases is 58.75 centimeters. Okay, next page. One more page for this lesson. 2 problems to go. All right, so the position of a particle is given by this function, position function, where it's measured in feet. Find the net and total distance the particle travels from half a minute to 1.5 minutes. So net distance. We are going to see, okay, that the net distance is equal to the absolute value of the position function at 0.5 minus at 1.5. We use some calculator and we get 9.367 feet. This right here is the net distance. That's how far the particle is from where it started. So in this 1 minute of travel time, it's going to go a little bit more than 9 feet. Now total. We got to see if there's any change in direction, left and right. So we need to think about the velocity function by taking the derivative. So the derivative of e to the 2t is e to the 2t times 2 for chain rule minus 8. And we're going to see where this is equal to 0. V of t is equal to 0. And we want to know if it changes sign, right? Because that's going to tell us if we've got any change in direction. N changes sign. So V of t is equal to 0. N changes sign. This is calculator. When t is equal to 0.693. That's when we've got a change in direction. Therefore, the total distance is equal to the absolute value, P of 0.5 minus P of 0.693 plus the absolute value, 0.693 minus P of 1.5. This is all calculator, and we're going to get 9.894 feet. You see, in this case, the total distance is just a little bit more than the net distance, just a little bit more than. Okay, one more example for you. The position of a particle function. Position of a particle function. This is the position measured in feet again. Find the net and total distance the particle travels from pi over 6 to 5 pi over 4 minutes. Okay, so net distance. This is just how far the particle is from where it started. So net distance. Net distance is equal to the absolute value, p of pi over 6 minus p of 5 pi over 4. This, of course, goes into your y1, that particle function, that position function, excuse me. Making sure you're in radian mode. We plug all this into the calculator, we get 0.989 feet. The particle is not very far from where it started, almost a foot. Now, total distance. We need to see if the particle changes direction, meaning does the velocity change from negative to positive or positive to negative. So taking the derivative of the position function, position to velocity, 1 plus 2 cosine of t. So we need to see where v of t is equal to 0 and where it changes direction. Calculator stuff, you're going to use second calc 0. This happens when t is equal to 2.094. What are we talking about? Minutes. 2.094 minutes. So the particle is changing direction, left to right or right to left. So total distance is equal to absolute value, position at pi over 6 minutes minus the position at 2.094 minutes plus absolute value, position at 2.094 minutes minus the position at 5 pi over 4 minutes. Everything in the calculator, we get 3.617 feet.